So today we will look at inheritance and composition in C++. So you might already have covered OOP, object-oriented programming concepts in Python or other language, and use it, in class inheritance. Is one of the fundamental concepts, as well as composition, and which one to use, and whether to use any of them actually, right? In fact, books go into maybe a little bit too much depth into inheritance. In fact, in real life, you should use inheritance sparingly, right? So first of all, what's inheritance? Idea of inheritance. You have some sort of class. Let's say you have a person class, and you have a student class, right? So an idea would be nice if the student class could already, and since student is a person, I hope, right? You're not robots, you are persons, right? So, it has an is relationship. Yeah, you are a person, so it makes sense to inherit these properties, right? Whatever persons are. And you have some student-specific properties, right? Teachers have their own properties and methods, right? And class functions. But of course, you have some common ground. So that's the idea, right? Again, but turns out not many things in real life are so nicely have this is relationship, right? So animals, dog is an animal, so of course we'll see the examples. A vehicle, a car is a vehicle and a truck is a vehicle, and things like that, right? Then you have nice tidy inheritance relationship. Again, skipping ahead to the conclusion already, composition is much more useful. Composition is you have something from somebody else, right? You have, cars have wheels, have engines, things like that, right? Which could be also based on the class design. Those are actually much more common, right? So you'll learn about inheritance, right? So we'll need to learn, we'll need to define some classes, right? Then we'll see actually how to derive class from a base class, right? Again. So, again, there will be some inheritance, public, protected, and private, actually, right? And we'll also learn about composition, right? So inheritance is a, right? Aggregation, composition has a, right? So, two ways of relating different classes. Again, remember, classes are templates, right? So, of some blueprint of whatever something is, right? A person or student or something, right? And we want to sort of like pass these blueprints along. So it's just like a blueprint of house. You have the general blueprint, and you maybe want to have something specific, right? You're building a house, and you are taking already some pre-existing design, right? You want to use pre-existing design, but you probably want to make some extra additions to this pre-existing design. That's where you have inheritance. Is a really nice approach. Okay, but let's see this in action, right? Right. So new classes from existing classes, derived classes and base class. The original, the OG class. Right, so I'm hopefully recording this, yes, and hopefully sound this, right. So the derived class inherits the properties, and properties also include, of course, member functions. Or I won't call them methods, but again, in C++ we call them member functions. Right. All right, welcome back. All right. So, now, right. Of course, things can get it says inheritance helps reduce software development complexity, but it can get extremely messy, right? Single inheritance not so bad, but when you get these multiple inheritance, and you inherit things from more than one base class, which I would generally would try to avoid, actually, right? And I won't make you do it in a midterm. You won't have to do multiple inheritance. You might have to do a single inheritance, maybe you'll have to do some classes, but you won't have to do multiple inheritance, because it's generally a bad idea, right? It's rare you see a nice example of multiple inheritance where it makes sense. Most likely you want to do some composition afterwards. So, you have a shape, right? So, inheritance hierarchy. So you have a shape, right? So circle is a shape, yeah, sure. Rectangle is a shape, yes, sure. Square is a rectangle, and which of course in turn is shape. So square would inherit all of the whatever shape things are, right? Collection of points, I guess, right? So so it works sort of, right? So again, I don't know what you would call a shape. What should the shape have actually, right? I think it's too generic, right? So let's look at the syntax, right? So syntax is you come up with your new name of your new class, right? And then you use a single colon, on you have member access specifier, whether right on default is private, on base class name, right? So this means that the private members of the base class are private to the base, they remain private in the base class, right? Meaning you don't get to access them as an inheritor, right? You inherit something from this base class, but you don't get to see the fun, the private stuff. The dirty laundry is not accessible. All right, so let's see if we have any more examples. I guess I'll just do an example on a code space. I think it's much more interesting than talking about this stuff. The cuddly space fork, right? We'll do some inheritance. Again. All right, there we are. Where's my terminal? All right, slowly but surely, reloading. My bash. Yeah, all right, looks like we're good. And I will start a new file. We'll call it. We have to start something again. I guess reload window. So, of course, before we want to inherit something, you need something to inherit from, right? So you need the parent or grandparent class as well, all right? So let's see if anything else interesting is here, right? Right. So also we'll be able to define functions as well, right? So let's look at C++ reference, C++ reference inheritance. Does they say anything good? Inheritance, right? Right. This is like 10 years old information, but still, of course, applicable, right? So number, right? Imaginary number. I don't like these great, examples, right? So use a colon operator, right? So, right. So now we have it working. I'll call it inheritance. And C++, right? Let's explore the concept of inheritance in C++. All right. So in inheritance, a class can inherit the properties of another class. All right. So the class that is inherited, that's where you get the money from, right? The base class, right? And the class that inherits is called the derived class, right? So, right. So let's start something. Include idle stream. I wonder what kind of example we'll have. The namespace standard, right? And we have a base class. So it's going to be person, animal. Okay, sure, why not, right? So let's do an animal, right? And we have some, remember, public, right? So it can eat, it can sleep, and maybe some properties, right? Maybe let's do properties too. Some properties. Well, I only have void eat, but maybe age. I'll do age. Age. All right. I can sleep. I can eat. Okay. All right. Some public properties. Some public properties. All right. Yeah. I'll do private hates. I'll do a stream. I'll do string. Right. Include string. Right. Include string. Right. Hates. Right. How should I say? Prefers string, not name, hates, or loves, or habitat. Cuisine. We'll do cuisine. All right, string cuisine. All right, why not? So this is private by default. All right, and we'll do name as well, right? We'll do string name. Okay, why not? Right. All right, something like that. Okay, so that's our base class, right? So we'll come up with dog, right, or something like that. Derived class dog. So what this means is that So of course this means we get all of the goodies from the public, but we don't get the cuisine, right? We won't have the cuisine by default, right? Public animal. So we'll see, do we have a cuisine by default or not? Right, that's a good question actually. You'll need, of course, constructor, right? You'll need a constructor, right? Probably want to do that as well, or do we have to do it by hand, right? Let's do a constructor. All right, let's do a constructor. Constructor. Yeah, animal, this name, string, age, cuisine, right? Probably want the constructor, right? Otherwise, it's kind of boring to make it. Okay, so animal gets constructor as well, right? The constructors we won't worry about right now. We can do it later. So now let's use it. Yeah. So dog, right? Now what's the problem here? What does this not like? No instance match the argument list. Rover 5 omnivore. Let's see if this is a problem. So my constructor name age looks okay, but let's see if this compiles. I don't know. Let's try it. Why not? It's a little bit iffy, right? There's something you might need to actually define this. So G++, again, is all inheritance, and we want all to inherit doggy or inheritance. All right. Let's see if this works. So it's going to say no. So okay. So dog, right? The constructor. We don't have the animal. So I think we need to actually. Dog needs its own constructor, right? Can we use the actual animal constructor? Maybe we'll get to this in the slides. So maybe I'll skip this part for now. So I'll just have, if I have a dog, can I do this? I have dog. No, then I don't have. So this is legal, but then I don't have these values, right? So I need, of course, dog name bingo. Dog name age, right, and dog, that's it, right? Let's see if this works. So what's dog? Right, so of course we didn't make one, right? Dog, right? Let's see if this works. What happens now? Yeah, Christopher bark in dog, which is a non-class type dog, right? So dog does not have it. No, we'll see if this is maybe, all right, so you need to pass this. So what? Do we want constructor? Yeah, that would work, alright. Or you say bingo 5 omnivore, that's certainly a possibility, right? But we would like to probably use constructor, so string with 3, that's default constructor, right? Default constructor. So this would be legal, right? Right now this would work, I think. Let's see if this works. Ding dong name and age. Let's take a look. Now is it gonna compile? Right. Or do we have to actually use it? The question is, why don't we have access to this dog, right? We are inheriting. Let's take a look at the slides, right? So member list, right? Public members of the base class can be inherited as public or private members, right? And we can include additional members. And we can redefine the public members, right? So, right. So scope resolution. We don't want to redefine, right? We don't want to redefine box type, right? So, derived class constructor cannot access private. Initialize only public. Alright, so let's look at this again. So, we have public, number, imaginary number, right? We have a constructor. Let's see here. This colon, mReal component. Let's take a look at this part here. Okay. Okay, this makes just two numbers, using two numbers. Real component. Do we need to have a virtual? this is gets a little bit tricky. Alright, so let's take a look what else do we have here. Going on destructors. So constructor cannot directly access. Okay, let's see what happens if we just get rid of all of the extra stuff, right? Let's get rid of the constructor. We don't do anything. Can we do this here? And of course we don't have anything, right? Can we just do this for now? Let's see, can we compile it? Just make a dog, right? Do anything, right? What actually do we have? Can we bark? Can dogs bark? Dogs should be able to bark, right? And then of course, let's take a look. I think the issue is here, right? What's new? Oh, looks like there's something code space is messing up the retry. It's not saying. Oh my God! Looks like code space is doing something else. Inheritance. It's not saving. It's not failed to save. Huh? Interesting. Read only file system. Interesting. Do they open it anywhere else? Or code space is messing up right now. Can I make revert? Alright. It's not big, it's not on save. Alright, so we have animal, right? Maybe let's skip the constructor. Can we do that without skipping, right? Alright, let's skip the constructor. Again, it's not trying to save, so it looks like we have a problem here. Technical problem. As far as the code goes. This looks okay. I'll need to start somewhere else, I guess. Or maybe I have to define, so public is fine. I don't know what's happening here. I guess I'll start. Let's see if we can just quit it. Save. Nope. I guess I just quit on save. Alright. So can I make a new file? I'll make a file test. Nope, I can't save. I guess I have to quit basically, right? Something's wrong with the virtual machine. Alright. Do I have free space? I have free space. Free, yeah, htop does work. I have two codes, I have memory, I have everything is nice, so this is not the end of the world. I guess I'll just stop here and try again, right? I will try turning it on and off again, right? So we'll try that. Okay, so let's do it over. Where's my code? Where's my GitHub? Maybe something GitHub is, is it down? Looks like something is not right. Looks like GitHub is something is not right. As you know, there's a site called Is It Down or Is It Me? Or is it me, right? Down for everyone or just for me, right? So you can check Facebook, looks like Discord, Stake, Janitor AI, whatever Janitor AI is, right? But if we try GitHub, we can see, well, no last outage was on September 20th, it's 15 minutes. Of course, that does not mean you have problems, right? It could be, of course, something else, right? Slow. Germany, inaccessible, error C, so there's some stuff happening, right? This is like today, but of course, considering there's millions of users and only 4 users say something, that's not really not the end of the world, right? So, let's go back to our repository. You're gonna have to find it. My repositories on, yeah, it looks like just something's not right. Code space. Yeah. Is anyone else using code space right now, or no? Bless you. Or is everyone else asleep? More or less, right? Yes, looks like there is a problem. Of course, they could restart, but there is something wrong with this code space. Unfortunately, something wrong. Yeah. All right, let's check. Let's do some debugging. All right, I'll need to. Do we have anything here locally? PowerShell, right? Do we have Visual Studio? Oh my God! And I can't even run PowerShell, so can I run command? Okay, well, the administrator has gone really strong here. I don't know. We need some in the PowerShell here. We can't really do anything. A lot of people say Octopus is like an alien, but the strange thing is, as you get closer to them, you realize we are what? What's it called? We are aliens. Very similar from the documentary, My Octopus Teacher. Okay, interesting. All right. So we are like octopus, apparently. All right. That seems like the case. Okay, but yeah. But I digress. Okay, I'll take this off. Let's see if we get other way of other. I guess I could try Replit, but Replit is horrible. But I can try. I had some examples on Replit here, right? So yeah, let's see if this works still. Yeah, this was previously like a year ago, 2 years ago. Right, probably I'll need to log in. Yeah, I'm still here, but it's not gonna be. It's Google. GitHub. I guess I can GitHub. Alright. So Replit, of course, is much weaker than CodeSpace, but at least it works. Okay. So we have the vehicle class right here. Right, so this link is in my repository, something like here, inheritance composition, right? So, right, I have a vehicle, right? But it has publicly, it has wheels and it can honk, get away from me, right? So the thing is, eventually later on we'll need to make a virtual get wheels function, right? Right. And also we are creating a color, protected, right? So publicly, right? So we're going to derive a new class. It's going to be a car, of course, right? On has ABS, meaning of course not apps, but has a automatic brakes system, right? Yeah, ABS, right? So on public, right? Everything is privately defined. So we define void car honk, right? Oh, that's car honk, right? And we can honk internally, right? I call private vehicle honk, right? So I define get wheels, the inherited, get wheels, override, return 4 wheels. String get color, right? Set color, new color. So you can also make some composition, right? You can add some wheels, we can add some handlebar, right? Class bicycle, okay. So let's see, we have a car, and we can get the new wheels, and we'll do the bicycle afterwards. Right? That's going to be a composition example. Right? Let's compile it. Yeah, run. All right. So it works. So let's see how we implement it. So car. Okay. Yeah. Car. New car equals car. Okay. So that's the syntax. Again, hopefully I'll check again the code space again. Active. Let me shut down. Stop code space. Right, on. Let's try it again. We committed changes, that's fine. Let's do it again. Maybe this time it will work. So basically, I'm hoping we'll just get given a different virtual machine and hope everything just works out of the box. Right? Let's see. Do I have my inheritance anywhere? I do have my inheritance. All right. There's my inheritance on my animal, but of course it's very basic. All right, that's okay, because we were not using this animal anyway. So let's make a dog. Let's inherit. Let's create the right class. Dog. Right. All right. Public dog. I can bark now. Right. Dog. Dog eat. Dog sleep. Bark. I don't know if this is gonna work. Right. So G++. Well, this looks very suspicious to me, because this is not, we don't have we need to create it, right? We don't actually here, right, equals, yeah, this is what we need to do. Yeah, yep. All right. That's what AI, you don't trust AI. Trust but verify, I'm sorry. So your inheritance, and let's see if this works. Oh, inheritance. Yeah, it compiles. That's a good step. So we should now should everything work out of the box. Yes, I can eat, I can sleep, I can bark. Good doggy, right? So good doggy. We don't have any, of course. We don't have any properties here, right? So we just have member functions. Let's add some properties. We want probably a constructor which will save some data, right? So let's do some construction, right? So name, string name. Okay, let's see, do we have name? Let's do a name. String include, not pragma region, but include string, right? And we'll do a name, string name. All right, and then of course we want to do a constructor. Animal, right? Animal created, but we want a name, right? String name, right? And of course, this name is name, so we save the name, right? Now, of course, is this going to work? Not anymore. So we're going to call it what? What's good name? Dog? Bingo? I don't know. Anyone have dogs? Nope. But dog name?
I don't want to tell it.
Don't want to tell it? It's embarrassing?
No, it's not embarrassing. My dog is called Gary.
Gary?
Yeah.
Okay. So good thing there's no Garys here in the class, right? Right, so somebody, there's I forgot which name it was, so I'm not remember, it was also like, it was a co's name or somebody said, and it was, it was really embarrassing somewhere, right? So same goes for cats as well, right? All right, so yeah, okay. So we'll use I don't know, Spot, I guess, right? Spot, of course, right? Which is the English one, right? So dog Spot, right? Now, did we do it correctly? Why doesn't it say we have string name animal, right? How can we do this here? So we don't have it. Do we have to do this? Because in Python we don't, right? But we need to call constructor here. Constructor. Right. So basically, we pass through the so now it should work, yeah. Right. So basically, dog created. Is this going to be enough? The question is, name, dog's name. The name is, right, so let's see this. Right, so let's see, this compiles. It compiles, that's good. On now, so let's see what happened. We created, yes, my name is Spot. So what's it? So let's pay attention to this spot here. Pun intended. Right. So when I create the dog, right? So obviously the dog constructor is going to be called, right? String name, animal. So, but the interesting point is here. So this part here actually turns out to calls, right? This obviously called as well, right? Animal created, dog created. So this actually also gets called, right? So animal. By using this colon syntax, my doggy constructor, I also use the animal constructor inside. So by using, we call the base constructor, right? So remember in Python, you have to call the base constructor, you have to call super, or there's keyword super, right? Here you don't have to do it. There's ways of doing it, but you don't have to. So this automatically gets called. If I don't have this, right, it won't be used, right? So right now, you see the sequence, animal, so here, or the base class, right, passing the name. Now we use, we can use the name of the derived class, and we can pass in the name, right. Okay, so, all right, so that's a very simple example, all right? And again, the issue of it is getting kind of was sunny, can't see anything. Okay, that's better. Now, if you have anything private, right? What could be private for an animal? I don't know, like food, allergies, maybe allergies. I don't know. All right, allergies, right? Allergies. So this will be private by default, right? Right. I could say private, right? Now, how do I get this? Right, get allergies, right? So my allergies, right? So I need setter, right? And I need a getter, right? Get allergies, right? These are public. This is private. So now, of course, so I can do what? I want probably the allergies as well, right? So let's do that. Let's add string allergies, right? All right. And here, of course, I can do this, right? All right. Now, all right. All right. And now, of course, my constructor is different, so I need to do name and, of course, also allergies none. I could pass, right? Like this is okay. So here, of course, none, because I'm saying, okay, here we have no allergies, right? So here I could do, of course, allergies as well, right? String allergies, right? Right. And of course, I would pass them here, right? Right. So it is a little bit, the syntax is a little bit messy, right? So now, of course, my name is, my allergies, right? So no way to get basically directly, right? So that's the main point, right? You need to use a getter, right? You need to use a getter, public getter, right? So that's the whole thing of OOP, of course, is you hide this, right? So even if you're inheriting, of course, what is dogs allergic to? Cats. So let's do cats, right? Fleas, okay, fleas, cats, right? So fleas, but actually I would say cats, right? So this guy is really afraid of cats. So let's see. Let's see now. Let's run it. And we can run it. And yes, I'm allergic to cat. Indeed, he's allergic. Spot is allergic to cats. So yeah, I can. So I could have, yeah, I could have another dog, right? Also, of course, reminder, of course, I can still make animals, right? This regular class is not abstract, it's just a regular class, right? So I could use just a regular class. Of course, I could also, since animal class is a normal base class, right? Animal, right? And also called octopus, right? Allergies, I don't know, shellfish or something else. Okay, right? And this also will work, right? Animal eat, right? Animal sleep, but no, of course, no animal bark, right? Because of course the dog has this specific, right? And animals don't have bark by default, right? So this, of course, will work. Again, assuming, of course, my companion, yeah, animal created, right? Animal sleeps, animal barks. Not barks, sleep. It just does not sleep. It does not bark. Okay, so that's the whole basic idea. Again, the syntax is a little bit messy, like I said. I mean, I'm much more comfortable with the Python syntax, but C++ syntax, of course, not so. It's not so bad once used, every day, right? But now, let's, like maybe 1 minute before the break. No, maybe a couple more minutes, right? So we can do again. Cannot directly access private members. We can only do the public members, right? So destructors, again, a derived class, right? So how would you destroy stuff? Of course, when it goes to the scope, it's going to be involved automatically, right? So define new classes, create new header files, right? Create new derived class, include commands that specify where the base class definition will be found, right? So it's possible you have the base class in one file, right? And your derivation could be in another file, actually. That's completely normal, right? Because maybe there's a super class, right, where it's one place, right? Of course, the problem is that at some moment, you know, you lose the track of where everything is, right, and you have to track it down, and that's why these long inheritance chains get sort of messy, right? Because you are also inevitably overwriting some functionality, right? So, of course, again, pragma, right? Header, right? So iOS is the base class for all stream classes, right? Yeah, look at this here. So iOS, when I type something like OStream, right? What do I call? Right, this example here, right? iOStream, right? Right, actually, right, there's hierarchy, right? I'm inheriting actually from iOS, actually, right? So, and of course, iOStream, in this case, my iOStream actually is both the input, output together, right? So, you could say that C++ is eating its own dog food in its standard library, meaning it's doing, you know, the inheritance thing there, right? So, protected. So, yeah, let's go to 11:55. So let's do 4 more minutes so we can do the protected classes now. So what does it mean? Protected means to give a direct class, let's do a protected property, right? This means that it will not be accessible outside, right? But protected, but it will be possible by derived class. So let's take a look at this here. Where's my inheritance, right? Do protected. Yeah. Protected. Okay. So protected. Right, breeze, right? So this will be callable by derived classes. Right? Right, but not the outside world. So that's the main point, basically, right? Protected, right? So breeze, so I can do also breeze, right? And where can I do it? Dog sleep, dog breeze, right? It should be, come on. I don't see it here, but actually, right? ID says I can't breeze. Well, hopefully I can, right? Breathe. I think it should, yeah. Protected, but it should work. Let's take a look, right? Direct access. Let's take a look at this. Protected. Public can't, right? Okay, I got you. All right. Yeah, this will not be protected, but however, right? Because that's public, right? However, what I can do, right? I can do create a. This will work. I can create a. We can use the protected doggy breeze. Void doggy breeze, right? We call the protected. We call. All right. So that's the thing. Okay. All right, so now that won't work, right, obviously, but this one, doggy breeze will be doggy breast. Yeah, it's public. Okay. Yeah, so it gets really messy, and again, in general, you know, it's, which one should be public, should be private. Of course, you have a meeting about that, and so on, right? And again, in a way, it's important. Another way, nothing gets done. You keep thinking about all these protected public things in real life, right? So that's the issue, how much time you want to spend on this, right? So what do you want to protect, basically? So all inheritance, yeah. So I can breathe, finally. Okay, so that's good. Right, so this is a protected, right? So callable by derived classes, right? But not public, but not by the outside world, right? So you see the difference, right? So I cannot do it directly, right? It's protected, but I can use doggy breast, which uses this inside, right? Okay. So are we pretty clear on that, or so on this protected? Okay. But main thing, of course, is private and public, of course, is more important. So the protection is a little bit sort of like in between stage. All right, so that we solve this on, yeah, so for public protected members, public members of A are protected members of B, right? Protected members of A are protected members of B, right? Private members are hidden in B, only to public or protected members of A. So again, you have very fine-grained control of what you want to access or what you don't want to access. So, all right, let's take a 15-minute break and let's continue at 12:10 then. If there are no questions. I'll add this to the code.